Got the point? I would like to repeat it for you. I would like to repeat it. See, earlier, the first question gave you matrix A. You wrote the characteristic equation as what? Lambda minus the first entry multiplied by lambda minus the diagonal second entry. You subtracted the product of off diagonal entries from it. The equation became lambda square minus lambda minus 6 plus 10 equal to 0. And here you observe it becomes lambda square minus lambda plus 4 is equal to 0. You find out the roots using the formula. So it becomes lambda is equal to minus of minus 1 plus minus under root b square minus 4ac. So that gives you 1 minus 16 and upon 2. So ultimately the answer is lambda is equal to 1 by 2 plus minus root 15 by 2 I. So the roots are complex with real part alpha is equal to half, which is positive. So you said it was spiral source. Okay. In the second question, A is given to be matrix minus 3, minus 2, 5, 2. You wrote the characteristic equation as lambda minus the first entry minus 3. So it becomes lambda plus 3 multiplied by lambda minus the second diagonal entry that is 2. So product lambda plus 3 into lambda minus 2 minus the product of the off diagonal entries. The product of the off diagonal entries was minus 10 and that you are subtracting. So it becomes plus 10 equal to 0. Ultimately, the polynomial becomes lambda square plus lambda minus 6 plus 10 equal to 0. So what you observe, the coefficient of the lambda, the linear term here is positive. If the coefficient of lambda is positive, means if at all you are getting complex root, the real part of the complex root is what? Negative. So you are observing here, we use the formula lambda is equal to minus 1 plus minus under root 1 minus 4 times 4. So that gave you 16 and upon 2. So what you observe, alpha is minus 1 by 2. So it being negative, you have written it to be a spiral sink. Is it clear? So this kind of MCQ questions you have to solve. So to be fast, you write the characteristic polynomial directly, observe what happens to lambda and observe whether the roots will be complex or not. So b square minus ac, if it becomes negative, the roots are complex. Otherwise, don't go for this. So let's have the third question. This is question 3. Let us write our matrix A. Matrix A is 3 minus 2, 5 minus 2. 3 minus 2, 5 minus 2. So what will be the characteristic polynomial? Lambda minus the very first entry, that is 3, multiplied by the second diagonal entry. So it gives you lambda minus minus 2, making it lambda plus 2. From that, you are subtracting the product of the off diagonal entries. So it becomes minus 10 and is equal to 0. So what you observe here, it is going to give you lambda square minus 3 plus 2 gives you minus 1. So minus lambda minus 3 into plus 2 gives you minus 6. And this minus minus makes it plus 10 and is equal to 0. So what you got? Lambda square minus lambda plus 4. is equal to 0. So I think you are getting the point. Again, I would like to concentrate to the coefficient of lambda, that is minus. One more thing, b square minus 4ac is going to be minus 1 square is 1, 1 minus 4 4 is 1. So it has to be ultimately negative. So if you want, let us write the formula. Lambda is equal to minus b plus minus under root b square minus 4ac. I think you are quite familiar with the formula, so there is no problem. And upon twice a, so what is the value of lambda you got? Lambda is half plus minus root 15 upon 2 I. Why I? Because you're getting minus 15 inside the root. So for the minus sign, I have written I, and the value I have written adjacent to it. Okay. So I feel the thing is quite clear. Lambda has a real part alpha plus half. It being positive, we call it a spiral. What? Yes, it must be spiral. Yes, Suvarna, what it must be? Spiral. Source. It must be spiral source. Okay, if it is positive, we call it as source. If it is negative, we call it as a sink. Yesterday, we have seen this. All right, I would like to move to the fourth so that you'll get enough practice. So this is question 4, and let us have our matrix A equal to, it was minus 3 5 minus 2 3, minus 3 5 minus 2 3. So let us directly write down the characteristic polynomial as lambda minus first row first column entry, that is minus 3, so it becomes lambda plus 3 multiplied by the second diagonal entry, that gives you lambda minus 3, and from that you subtract the product of the off diagonal entries that is minus 10 and is equal to 0. So calculate it. What it becomes? Lambda square. Now you see plus 3 and minus 3 is going to give you what? Lambda square minus 9. A plus b into a minus b formula. And then you have plus 10 is equal to 0. So what is your equation here? You are getting lambda square plus 1 equal to 0. So which case we are handling? The case of lambda square plus beta square is equal to 0. Means purely imaginary eigenvalues. So if the eigenvalues are purely imaginary, so can you tell me what are the eigenvalues here? What is the value of lambda? Yes, come on. Plus or minus I. Okay. If you are not able to solve it, use the formula directly. from here. So what do you do? Lambda is equal to minus b. There is no b. So 0 plus minus under root. B being 0, it will be 0 minus. And 4ac makes it minus 4. And upon what? 2a. So it gives you 2. So what you have got? Real part is 0, no doubt. And you have under root minus 4. For minus, you are going to place I. That's all. For root 4, it becomes 2. And there was upon 2. And there was plus minus sign. So ultimately it is plus minus I. Did you get me? I hope you're getting the point. Or you may call it as what? You may call it as lambda square minus I square equal to 0. Okay. So if you don't want to use the formula, you may go like this also. Lambda square minus I square, because I square is minus 1. And your equation was lambda square plus 1 equal to 0. So for plus 1, you can write minus I square. And this will give you the factorization as lambda plus I multiplied by what? Lambda minus I, and is equal to 0. So you got two values of lambda, that is either plus I or minus I. So this is what you are getting. So your answer is what? Pure imaginary eigenvalues. The case is pure imaginary eigenvalues. So in case of pure imaginary eigenvalues, what are the phase portraits? What are the phase portraits? Yes, have you read it yesterday? These are the phase portraits. So they are nothing but circles. Phase portraits are circles. Phase portraits are circles. Okay. Any doubt? Yes, anybody wants to ask anything? Are you working with me or simply watching the screen? I hope I'm reaching to you. Is it fine, Dolly? Okay. All right. Let us move ahead. So two more examples are there, but with the help of the same figures they are managing with the matrices. So I hope you'll solve the rest too. Please copy down the two matrices and try to solve it. What up till now you have learnt is, if the roots are purely imaginary, you get circles as the phase portraits. If your eigenvalues being complex with real part positive, you call it as a spiral source. And if they are negative, real part is negative, in that case you call it as a spiral sink. That's all that you have learnt up till now. And talking of the phase portraits, you know very well, if it is a spiral sink, it falls in, it goes towards the origin. So towards the origin, spiral towards the origin. And if it is source, it goes out away from the origin. That's all. So only that thing you have to keep in mind. Is it fine? Is the thing clear to you? Okay. So, so you can watch here the answer to the questions given there. The earlier one, the very first was simply circular because it was purely imaginary. So there you find the circles. Second also you find the circles, these portraits. Third one, you are watching it spiral one. So do you observe it to be spiral one? They're all spirally arranged. Okay, they are spirals. And the direction of spiral is going away from the origin. It is coming out of the origin. In case of fourth one, you see it is again spiral but going towards the origin. The arrows are going towards the origin. So this way you should be able to um, learn which one is the correct one, because the exam is going to be MCQ style exam. So there you have just to go whether uh, it is going towards the origin or away from the origin, whether it is spiral or it is circular, so that you have to decide. Okay, whether it is a straight line. So there is no question of straight line in case of complex ones. So I feel all of you are quite familiar now with this. So might be they will give you option like 1, 2, 3, 4 figures from here may be copied, and you may have to choose which answer is the correct one. Okay, so this kind of MCQ style exam may take place. Okay, so any doubt from your side? Yes. Any doubt? Come on. So if not, for the time being, we will stop here itself, and in the afternoon we will meet at